Hello everyone, my name is Mike and welcome to another Python video. This time we're going to be solving this exercise. As usual, we're going to be using the platform codeworks.com. Okay, so let's get started. I'm going to read the instructions. Implement a function that adds two numbers together and returns their sum in binary. The conversion can be done before or after the addition. The binary number returned should be a string, okay? This is something important. It should be a string, okay? So basically what we have to do is to add two numbers together and then convert them or convert the resulting number into a binary number. We can actually take the two numbers, convert each one of them into a binary number, and finally we can add the binary number to get a result. But I think that's more complicated. So the first thing we're going to do is to take the two decimal numbers and we're going to add them together. So we have the result here. So this variable that stores the result is called iterating sum, and we're going to convert this number into a binary number. So if you want to do this, you have to know how to convert a decimal number into a binary number. So I'm not going to explain exactly how to do that, but I'm going to leave a link in the description below to the video I used to learn this. This is very, very easy. Here we have an example. We have 75, and the 75, and the resulting number, the binary number is going to be 100111. Okay. There is something important here I want you to notice. As you can see here, we have 1, 2, 4, 8, 16, 32, 64, 128. Okay. This is the same than having 2 to the 0 power, 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power, 2 to the fifth power, 2 to the sixth power, and 2 to the seventh power. So, for example, this 2 to the second power is going to be 2 times 2, and that equals 4. That's why we have a 4 here, okay? This is important because we are going to use this algorithm in order to know how many digits we are going to have in our final binary number. For example, in the case of 75, we're going to have 1, 2, 3, 4, 5, 6, 7 digits. And that's important because that's what we're going to be using in our code. Okay, let's get back. Okay, the first thing I do, I actually have a temporal variable here. This temporal variable is going to be the number of digits. Okay, here it says number of digits in the binary number. Okay, so I'm going to say if 2 to the 0 power in the first iteration is lower than iterating sum, the resulting number of the sum, then we are going to add 1 to temporal. So since we start temporal variable in 0, it's like we're going to be here. Okay, 2 to the 0 power is going to be 1. So if we have the resulting number, iterating sum, that is higher than 1, then we know that at least we have 2 digits. So that's why we add 1 to the temporal variable. Then we're going to check this. Let's take the 75, for example. In the second iteration, the while loop is going to do this. Okay, 2 to the first power equals 2. Okay, is 2 higher than 75? Okay, no, it's not higher. So increase by 1 the temporal variable. So now we're going to have 3 digits. And then it's going to be the same. Is 4 higher than 75? No, okay, and so on. So when the while loop reaches here or this point, it's going to be like, okay, 75 is higher than 64. Yes, okay. Then end the while loop. So that's what we have here. When this operation is higher than the resulting sum that we had before, we're going to end the while loop. Okay, and we finally add or increase by 1 the temporal variable. This is going to help us because we need to compare this number to the next number of the 2 to the power n. Okay, so we need to compare we need to know where this number is located. For example, we need to know if 75 is higher than this, but we also need to know if this number is lower than this 128. Okay, so that's why we add that's why I increase by 1 the temporal variable, because I need to know the next number. I need to make sure that the next number is higher than my current number or the calculation of the sum I made here. Okay, so now I'm going to create an array, because I'm gonna save, or I'm gonna store each of the digits of the binary number in this list. Actually, it works like an array, but it's a list. In Python we call this list. Okay, so this is an empty list, and then what I do here is an algorithm that will let me know, for example, if we have 7 digits like here, the algorithm is going to check, okay, do I have, what do I need to know to put a 0 here or a 1? Okay, there is, if you check this video, you will know how you can know if you have to write a 1 or a 0, okay? Based on that, that's what I do here. I check, I use for digit, I mean for each digit in the number range, I use range because I already know that temp is the number of digits. Let's say for example that we have 3 digits in our binary number, okay? But since we start in, okay, the list start, or this range starts in 0, we're going to have 0, 1, and 2, 3 elements, even though temp is 3. So in order to reach the number 3, I'm going to add 1 to temp. So, so we have the iterations we want, okay? Then, here, this is basically what I'm doing is what you can learn from this video. I make a comparison, and based on the result, I'm going to add a 0 or a 1, okay? And as you can see here, we have some subtractions here. 75 minus 74 equals 11, okay? This subtraction, then we have 11 minus 8 equals 3, then we have 3 minus 2 equals 1. Okay, these subtractions are done in this line of code. This is the minus, okay? So this is really easy. This is really basic stuff. And finally, we're going to have a number, okay? The output number is going to be a string. Here we have integers, and then we have to convert it into a string. We can actually convert the number here in these lines, but I decided to separate it, to make it apart, because I think it's going to be more easy it's going to be easier to understand. So I create an empty string, and then I use a for loop. I'm going to say, okay, my string is going to be is going to be made based, or it's going to have the elements of the list I had before. So remember that in the beginning we have a list like an array. So we have in this array we're going to have n elements. So since each element is a different element, I need to add them together, to put them together in order to make a unique element. That's what I do here. I say, okay, take each element of the final number list and then add it to the string, to the output number string. So in the end, we're going to have a number like this. Okay, 0, 0, 1, 1, 1, 1. We have these zeros here, or it is going to be usually 1, 1, 0. But we have that 0 there because we added, we increased by the 1 the temporal variable here. That's why I have this 0 here, because as you can see here, that 0 would correspond here to the 128 in the case of 75, okay? So it's going to be the same like in the decimal numbers. This 0, we need to eliminate these zeros because they don't have any value, real value, okay? So in order to do so, I'm going to convert the output number. My original string is going to be this. I'm going to convert this number into an integer, and then when I convert it into an integer, we will only have these values. And the zeros will be eliminated. But since we are required to return a string, okay, I'm going to take these values and I'm going to convert it back into string. And then we're going to have the final result. That's what I do here. First, I convert into an integer in order to eliminate the first 0 or the zeros to the left. And then I convert the integer into string in order to have the result. And I'm going to check it now. Test. As you can see, all the tests have passed. And I'm going to click on attempt, and I passed all the test. So I think that's all for now. As you can see, there is no failed test, so this code is working. So that's everything for now. I hope you enjoyed this video, this short video. And if you have any questions, you can leave your comments, your questions in the comment sections. See you later.